Multimeter. A multimeter or a multi-tester, also known as volt-ohm meter (VOM), is an electronic measurement device that combines several measurement functions in one unit. A typical multimeter can measure voltage, current, and resistance. There are mainly two types of multimeter used: analog and digital. Most commonly used is digital type multimeter. Now let's use multimeter to check voltage and current in series and parallel circuits, and let's test if our theory is correct. This is a common multimeter. You can easily find it in your lab. In this multimeter, you'll be able to see multiple markings here. This marking denotes you can calculate resistance, you can calculate voltage in DC, voltage in AC, current in AC, current in DC. This multimeter can also be used to calculate the continuity across the circuit. So this is a knob. You can easily twist it to your suitable value or type. You can even have a light here. Depending on the multimeter you're having, you can turn it on and off. So these are two probes of the multimeter. This is positive and this is negative. These probes can be further connected or disconnected to calculate voltage and resistance. If you connect it here, you can measure current. If you connect it here, you can measure voltage across the circuit. This is the display unit where the values are displayed, whether it is voltage or current. So, what is continuity? This is a quick audible alarm test using a digital multimeter to determine whether an electric current or wire is complete or broken. This test can be applied to a circuit as a whole or in a section, on individual components or sections of wirings. A break in the continuity can be caused by mechanical damage, corrosion of components, or simply a switch being left open. Your circuit might be right and perfect, and you should not seem to be wondering the fault by looking at every connection, but the better way to troubleshoot is to check the connections running through the circuit. It will help you to determine minor faults. It basically checks whether your circuit is open or closed. Isn't it interesting? Checking continuity is the basics of electronic troubleshooting, and multimeter suits the best for it. Let's learn how to check continuity. To check whether a circuit is open or closed, let's check the continuity of any circuit. To check whether this wire is continuous throughout the line, we have to check continuity of this circuit. So this is the multimeter I'm going to use. You can see a buzzer sound here. We have to shift our knob to the buzzer sound like this. You'll be able to see a battery sign. Now take the two probes, connect the two probes to the two terminals of the circuit or a wire. So you can hear a sound. Whenever you hear that sound, it means the path is continuous. If you won't hear the sound, it means the path is not continuous. Now let's check the resistance value of the two resistors here. To check the resistance value, I have to switch my knob to the value written here. You may see there are multiple number of values written here. You have to find the exact range of the resistance. I'm switching it to 2K. Now let's check the resistance. I'm connecting the two terminal to the two terminal of this. It's not showing anything. Let's shift the value more up. So it is 1 million ohms. Let's check the different resistance. We have this resistance here. We can also calculate the resistance value with the resistor counter port, but as we have a multimeter, let's check with the multimeter. So I'm switching my knob to somewhere at 2K. So it is 0.1. Let's reduce the value. Again it's 0.2. Let's shift it to 200 ohms. So the value of this resistance is 150 ohms. So So as you can see, we can also calculate the resistance value with the resistor. So we can see we can also calculate the resistance value with the multimeter. So let's see how to measure voltage of any DC device. So here we have multiple number of batteries. So to check the voltage, we have to first switch the knob to the voltage part, which is DC voltage. After switching this, we have to first check whether our terminals are properly connected. Now let's check our first battery. I'll connect positive to positive and negative to negative. Negative to negative. It is 1.9 or 2 volts. Now let's check the another battery. This is almost discharged, so it is 0.3 volt. Now let's check the another battery. This is 6.9 or 7 volt. Let's check another battery. This is 8.9. It means it's a 9 volt battery. This is how you can measure voltage of any DC device. So let's measure voltage across the parallel circuit. So we do have two probes here. We'll connect the first probe to the positive and the second probe to the negative of the circuit. Before that, we have to switch and check whether our terminals are connected properly. This positive terminal should be connected where the V sign is written, and the negative should be there at the common. Now, checking the voltage across this terminal, I have to switch the knob to the V, that is DC voltage. I can switch it to anywhere depending upon the range we are trying to take. You can see the decimal here. Now let's check the voltage across the first circuit, that is the first LED. It is 4.59 volts. Let's check for the another resistor. It is approximately 4.39 volts. As you can see, the voltage across the terminals are almost the same. So in parallel circuit, the voltage remains same. Now let's check the current across the parallel circuit. So this is a parallel circuit. Now let's check current across the parallel circuit. As we know, the current divides in parallel circuit. So let's check. We'll take the two probe of the multimeter and shift the knob to the current part. So this is 200 milliampere current, where it can measure up to 200 milliamps. I will jump one jumper cable which will make this multimeter in series. I'll connect it here and connect this jumper cable to the positive terminal. Now let's check the current across the first terminal, that is the first LED. It is 0.5. Let's check across the another one. It is 0.6. It means the current divides. The two different values shows that the current divides in parallel circuit. Now let's check voltage across the series circuit. As we know, the voltage drops across the terminals. We have two components here. The first one is resistor and the second one is LED. So as per the assumption and the theory we learned, the voltage across the resistor and the LED should change, but the current should remain the same. As we are checking the voltage first, let's check the voltage. First, we have to check the multimeter connection. The positive should be there at the V and the negative should be there at the common. And now we'll shift our knob to the voltage part depending upon the range we are trying to check. So now I'll try to connect for the first terminal. You can easily see I am checking across the resistor. The voltage across the resistor is 4.65. Now let's check voltage across the LED, which is 3.42. So as we can see, the voltage across the terminal is dropping. Now let's calculate current across series circuit. Before we calculate, we have to first understand that whenever we want to measure the current, we always have to keep the multimeter in series. So how to keep multimeter in series? So as you can see, this is a closed loop. I am disconnecting the positive terminal and connecting it the center. Anywhere at the center you may like. Make sure it is not connected anywhere else. It should not short to any other terminals. You can connect it any independent hole here. Now I will jump one wire to this positive terminal. As these are connected vertically, now I can make the circuit in series. Before I connect the probe, I have to shift my terminal to the current part. Let's shift the terminal to the current part. Now we have shifted our terminal to the current part. Let's check the current. To check the current, I have to shift the knob to the DC current. I'll switch backward. Now I'll try to find out and measure the current. Let's connect the two probe to the two end of this terminals. The first red color, the positive goes to the positive and the negative will complete the circuit by connecting it to the resistor. The LED started glowing. It is having 0.7 milliampere of current. Now let's go back to the different terminal. I'll first connect the positive to positive again, and I'll switch back to 200 milliampere, and I'll get back to the resistor again. See, it is having 4.5 milliampere. It is approximately 4.5 milliampere. Here you saw the current across the terminal, that is the series circuit, is same, but the voltage divides.